This is SpaceTime, Series 28, Episode 144, for broadcast on the 8th of December 2025. Coming up on SpaceTime, one of our nearest neighbouring galaxies being torn apart, a giant spider on the Jovian Ice Moon Europa, and a new study suggests the red planet Mars may have been habitable for far longer than previously thought. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered that the Small Magellanic Cloud is being pulled apart by massive gravitational forces. The findings, reported in the Astrophysical Journal Letters, are based on observations of stars known as Cepheid variables located in the Small Magellanic Cloud, which are moving in opposite directions along two very distinct axes. Cepheid variables are pulsating stars that expand and contract at set intervals based on their luminosity, and astronomers can determine their intrinsic brightness based on these pulsations. So, by knowing how bright they appear compared to how bright they really are, astronomers can determine how far away they must be using the inverse square law. Located some 200,000 light-years away, the Small Magellanic Cloud is a nearby satellite dwarf galaxy orbiting the Milky Way, visible in the southern hemisphere night skies. The study's authors found that Cepheid variables in the Small Magellanic Cloud closer to Earth are moving towards the northeast, while more distant Cepheid variables are moving in a southwesterly direction. These complex bidirectional movements along two different axes indicates that the Small Magellanic Cloud is being stretched by multiple external gravitational forces. Its neighbour, the Large Magellanic Cloud, another dwarf galaxy orbiting the Milky Way, is pulling it in one direction, and some other as yet unknown force is pulling it the other way. This study is the first to analyse stellar motions within the Small Magellanic Cloud, taking individual stellar distances into account. Previous studies that have investigated stellar motions within the Small Magellanic Cloud assumed that all the stars were roughly at the same distance from Earth, an oversimplification due to the lack of precise distant measurements, and that must have caused errors. So, to rectify that situation, the authors of this new study used data from the European Space Agency's Gaia satellite to analyse more than 4,200 Cepheid variable stars. By accounting for these individual distances, the authors were then able to analyse the stars' movements with far more accuracy than any previous measurements. An earlier study by the same group of astronomers had already determined that the Small Magellanic Cloud was being stretched by its bigger neighbour, the Large Magellanic Cloud. These two galaxies are gravitationally bound and they interact with each other, and these interactions are likely to have influenced their structure and evolution. One of the study's authors, Kenjo Takehara from Nagoya University, says there's also a possibility that the gravitational influence of our own galaxy, the Milky Way, or possible effects from past close encounters between the two Magellanic Clouds, is contributing to the torsion being seen. This new study also confirmed the idea that the Small Magellanic Cloud does not rotate, further suggesting that this relatively small, irregular-shaped galaxy has unique dynamics influenced by gravitational interactions with the Milky Way and with the Large Magellanic Cloud. These new discoveries challenge previous theories of the galaxy's structure and dynamics. It means astronomers need to rethink how the Small Magellanic Cloud, the Large Magellanic Cloud, and our own Milky Way galaxy interact with each other. That means that new computer simulations that consider the Small Magellanic Cloud's non-rotating nature will be needed in order to help understand these complex relationships. Meanwhile, astronomer Remy Indi-Bertau from the University of Virginia, who was not involved in this study, says the two Magellanic Clouds have been interacting with each other for millions of years. But this is their first encounter with the Milky Way.
The Magellanic Clouds, which consist of a pair of galaxies, a more massive one and a less massive one that we creatively call the Large Magellanic Cloud, and the Small Magellanic Cloud, are the closest extragalactic system, interacting in some way with the Milky Way, and they have somewhat lower abundances of heavy metals than the Milky Way. They are the nearest sizable neighbor galaxies to the Milky Way. And what I mean by sizable is there are some very small ones, But the Magellanic Clouds are the closest ones which are making stars and have some substructure and are participating in processes that normal galaxies, normal-sized galaxies would participate in. We believe, based on fairly recent work, that the Large and Small Magellanic Cloud are falling in from intergalactic space, so falling towards the Milky Way for the first time. There's a large stream of atomic hydrogen, which appears to be trailing behind them across a large part of the sky. And so their orbits were measured with more precise astrometry. You can run the orbit backwards in time and see that it goes out into intergalactic space. And we can actually trace the star formation history of the Magellanic Clouds and look at times in their history. There's one such time was a few 100 million years ago, where the rate of forming new stars was much higher than it is now, or there was a peak in that rate of forming new stars. And that matches with an interaction, a close passage of the small and large cloud. So we can go back in time and track how they interacted with each other, but we don't think they've interacted repeatedly with us. They've been together longer than they've been with us. Most of the universe is hydrogen and helium, but hydrogen and helium are not all that good at cooling, at radiating energy. And so if gas in galaxies gets warm, it's actually the trace heavy elements. They're few in number, but they dominate the re-radiation of that energy and the cooling of the galaxy, or the cooling of parts of the galaxy at least, and condensing and making stars, for example, and evolving. So we expect that when there's quite a bit less of those heavy elements, then that will affect the structure of molecular clouds, how they collapse, how they cool, how they make stars. So we want to study all these things in an environment. This is the nearest such environment that's a bit different, has a different range of physical conditions from the Milky Way.
That's Remy Indi-Batau from the University of Virginia and the National Radio Astronomy Observatory. And this is SpaceTime. Still to come, a giant spider on the Jovian Ice Moon Europa, and could the red planet Mars have been habitable for long periods of time? All that and more still to come on SpaceTime. A new study claims a unique spider-like feature on the Jovian Ice Moon Europa may be subsurface water seeping through the frozen crust following an asteroid impact. The findings, reported in the Planetary Science Journal, might point astronomers to the moon's potential for life. The spider-shaped feature is located on Europa's Menanan impact crater. The study's authors believe it may have been formed through the eruption of melted brines from a subsurface pool in the moon's icy crust following the impact. Europa is covered in a thick shell of ice, many kilometres thick. Below this is a global subsurface liquid water ocean. And astronomers believe the icy crust itself contains cavities filled with pools and reservoirs of melted brine. The study's lead author, Laura McEwen from the University of Central Florida, says if correct, it could inform scientists about the frozen moon's subsurface properties and its brine composition at the time of the impact. McEwen and colleagues have also studied Martian spiders, which are branching tree-like features that form in the regolith near the Martian South Pole. They applied that knowledge to other planetary surfaces, including Europa. While the Martian spiders form when dust and sand are eroded by escaping gas from below seasonally dry ice layers, the team's Europa work asserts that the asteroid-shaped feature more likely formed from an impact. McEwen says features known as lake stars here on Earth are radial branching patterns that form when snow falls on frozen lakes and the weight of the snow creates holes in the ice, and that allows water to flow through the snow, melting it and spreading it out in a spider-like pattern. She says on Europa, a subsurface brine reservoir could have erupted after an impact and spread through porous surface ice, producing a similar pattern. The authors have informally named the spider feature on Europa Damhanala, which is Irish for spider, in order to distinguish it from the Martian spider formations. Using numerical modelling of the brine reservoir, the authors obtained constraints on the reservoir's potential depth, which is thought to be about 6 kilometres below the surface, and its age, which is likely to be several thousand years old. To test their hypotheses, the authors also conducted field and lab experiments. They observed star lakes in Colorado and recreated the same process in a cryogenic lab at NASA's Jet Propulsion Laboratory in Pasadena, California, using Europa ice simulants cooled with liquid nitrogen. McEwen and colleagues then flowed water through these simulants under different temperatures, finding that similar star-like patterns formed even under extremely cold temperatures of minus 100 degrees Celsius. And that supports the idea that the same mechanisms could occur on Europa following an impact event. Observations of this spider-like feature on Europa have been limited to images provided by the Galileo spacecraft back in 1998. But the authors now hope to resolve this question with higher resolution imagery from NASA's Europa Clipper mission, which will arrive at the Jovian system in April 2030. McEwen says while lake stars here on Earth have provided valuable insights, the simple fact is Earth's conditions are very different to those of Europa. Earth has a nitrogen-rich atmosphere, while Europa's environment is extremely low in pressure and temperature. McEwen now wants to investigate how different pressure affects the formation of these features and whether they could form beneath an icy crust similar to how lava flows on Earth to create smooth, ropey textures. She says the new findings offer important clues about the subsurface activity and habitability of Europa, and these clues will be crucial for future astrobiological research. This is SpaceTime. Still to come, a new study suggests the red planet Mars may have been habitable for much longer than currently believed. And later in the science report, we look at the origins of the domestic house cat. All that and more still to come on SpaceTime. A new study suggests the red planet Mars may have been habitable for far longer than previously thought. A report in the Journal of Geophysical Research Planets says evidence of ancient underground water reveals the life-giving liquid once flowed beneath the Martian sand dunes, creating conditions that could have supported life for far longer than previously considered. The study shows that ancient sand dunes in Gale Crater, a region explored by NASA's Mars Curiosity rover, gradually turned into rock after interacting with groundwater billions of years ago. The authors compared data from Curiosity with rock formations in the United Arab Emirates desert that formed under similar conditions here on Earth. They found that water from a nearby Martian mountain once seeped into these dunes through tiny cracks, soaking the sand from below and leaving behind minerals such as gypsum, the same material found in Earth's deserts. These minerals can trap and preserve traces of organic material, making them valuable targets for future manned missions seeking evidence of past life. The authors say the new findings show that Mars didn't simply go from wet to dry. It suggests that even after its lakes and rivers disappeared, small amounts of water continued to move underground, in the process creating protected environments that could have supported microscopic life if it ever existed there. The discovery provides new insights into how Mars evolved over time, and it highlights the potential of subsurface environments as potential sites to search for signs of ancient life beyond Earth. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. It's been confirmed that a 60-year-old man who received a stem cell transplant to treat leukemia has now been in HIV-1 remission for years. The findings, reported in the journal Nature, could expand the potential stem cell donor pool for achieving HIV clearance. The man's the 7th known case of long-term HIV remission after a stem cell transplant. In previous cases, doctors have used stem cell donors with HIV with 2 copies of a mutated gene for the protein HIV-1. They use these donor stem cells for cancer patients with HIV to see if the transplant can also clear their infection. In this case, researchers say the donor had just one copy of the necessary mutation, and the patient was still able to stop HIV medication 3 years after the transplant, remaining HIV-free for another 3 years on. Paleontologists have discovered a world record number of fossil dinosaur footprints along an ancient Bolivian shoreline. A report in the journal PLOS One identified some 16,000 fossilized dinosaur footprints at the one site. The authors say it constitutes a world record for the number of individual dinosaur footprints, continuous trackways, tail traces and swimming traces. The footprints range in size from less than 10 centimetres to more than 30 centimetres. They record a variety of different dinosaur behaviours, including running, swimming, tail dragging and even sharp turns. The authors say that most of these tracks are oriented roughly northwest-southeast, with ripple marks preserved in the sediment, and that suggests that these dinosaurs were roaming along the ancient shoreline. A new study claims domestic house cats only arrived in Europe around 2,000 years ago. That's much later than previously thought. The findings, reported in the journal Science, offer new clues into one of humanity's most enigmatic animal companions. The new genetic studies show that all modern cats descended from the African wildcat, which today is found in northern Africa and the Near East. The researchers examined 87 ancient and modern cat genomes. They found that true domestic cats only appeared in Europe and Southwest Asia a couple of thousand years ago, and that earlier cats found in Europe and in Turkey were genetically European wildcats. Previous genetic studies indicated that cats may have dispersed from what is now Turkey into Europe alongside Neolithic farmers, supporting the idea that cat domestication began in the Levant during the rise of agriculture around 6,000 years ago. However, it still remains unclear whether these animals were truly domesticated cats or a distinct lineage of wildcats. Contrary to previous studies, the authors found that domestic cats most likely originated from northern African wildcats rather than those from the Levant, and that the true domestic house cat today only appeared in Europe and southwestern Asia several thousand years after the Neolithic. A new study has shown that a person's personality, rather than just their IQ, plays a big part in how gullible they are and how likely they are to fall to pseudoscience con tricks and snake oil salesman scams. Skeptics' Tim Mendham says the report shows that a person's openness to alternative ideas and how agreeable they are to apparent facts presented plays a big part.
This is one of those areas that we come up across every so often where you get people doing research projects on things, and this is a couple of psychologists from Missouri who end up stating the bleeding obvious. You think, why do you need a research project to find out that people who are more susceptible to trends of claims often show an openness to alternative ideas, and they are agreeable to someone telling them apparent facts? What they're saying is that people who believe in false narratives are often gullible people. And you think that's by definition what they are. It's not like a particularly new psychological aspect. Personality traits like even why some educated people, well-intentioned people who you think might know better, don't know better. It's basically because they're just gullible and open to different ideas. They're agreeable. They're very nice. There's actually 5 traits. The 3 other ones are conscientiousness, extroversion, and neuroticism, which is an interesting mixture of openness, agreeableness. But these various sort of pretty generalized personality traits are being used to explain why people believe in the paranormal or wellness claims and often false claims. And there are a lot of false claims out there, especially online. There's a lot of people offering everything from diet tips to reproductive conditions and stuff like that, and how to make $1 million, how to be your own psychic even. That are just people sort of saying stuff, whether they believe it or not. Unfortunately, you can't believe what you see on the TikTok video, but these sorts of people do, as the psychiatrists or psychologists say, because they're open and agreeable. I mean, it strikes me that sometimes the researchers are really not adding a lot to our understanding of why people believe. Saying they believe because they believe is not telling us a lot. They're saying people believe because they're gullible. Well, that applies to any con out there, any sort of person from a 3-card trick to a person telling you about a grieving.
Is it simply a lack of critical thinking?
It is. And that's something that we talk about. I mean, all of us apply critical thinking every day. How am I going to get to work or school? Do I catch the bus? Do I walk? Do I ride a bike? Do I drive? Do I catch public transport? Whatever. And you make that decision based on a few parameters and you work it out. And you'll say, well, this is going to be the most efficient cost-wise, time-wise. But in these other areas of the paranormal and people offering you health claims and things, we aren't, or most of us, or few of us, or all of us at times, aren't showing critical thinking skills. And critical thinking is vital to our understanding of dealing with the world out there. We don't notice it half the time because we do it so naturally. But there are other areas where people take advantage of our lack of formalised critical thinking, like these people offering health and wellness advice and people offering psychics and that sort of stuff, which in those areas which are a bit vaguer, the openness and the willingness of the poor mug punter out there, the victim, is taken advantage of.
That's the Skeptics' Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.